Okay, let's try that same process again. We're going to start with the factors and find the product, and then we're going to look at that and factor it back to these two parts. This is actually going to be the answer to the problem at the end, all right? Because we're just learning. This isn't how homework problems are going to be. I'm not going to tell you the answers. I'm just trying to help you show where these factoring methods come from. So remember, we have to do our 4 products because we've got 2 things times 2 things. So 2x times x makes 2x squared. 2x times -1 makes -2x. And then we multiply by 3. 3 times x is positive 3x. And 3 times -1 is -3. Once again, these middle 2 terms are like terms, so we can combine them. So the total product is 2x squared plus 1x minus 3. Now we're going to pretend like this is the beginning of a problem, and my instructions are going to be, factor this, please. First, you check for greatest common factor. Is there any number or power of x we can divide out of all 3? Nope, 1 is the greatest common factor, and it doesn't do any good to divide everything by 1, so we're not going to do that. Moving on, let's see if we can break it into 2 binomials. Think of this as a product. What 2 terms here would multiply together to give you 2x squared? Keep in mind that usually these are the same power of x. So it looks like it should be something like 2x times x or x times 2x. It doesn't matter which one you choose. All right, for now. Then we need the product to end up being -3 on the other side. So let's consider -3. If that's a product, what are the factors? Could be -1 times 3, or could be 1 times -3. In this problem, we're going to have to plug those in and try it to see which way it turns out to give us that middle term that we're looking for. It's not that easy to tell when one of these is a 2x and one of them is a 1x. So let's just try the first one. Let's try a 1 there and a 3 there. So that would be positive, right? Okay, so let's multiply this out the way we normally would. 2x times everything in the other parentheses. 2x times x is 2x squared. Then 2x times the 3 would give me 6x. Now I multiply -1 times everything over here. -1 times x and -1 times 3. Combine the like terms to see what the middle term turned into. 6x minus x is plus 5x minus 3. Compare that with the original problem here. Does this look the same as that? No, it's not actually. That means that the 2 factors we picked are not correct. So we need to do something different. I will tell you that the 2x and the x are fine. It's the other 2 things that are not right. So what you can either do is you can either switch the order around. You could put 3 here and -1 here, or you could switch the negative. And you just have to try these different things. Now, because we started with the factors, you could look up here and see what the difference is. Here's why it didn't work. Because the 3 was supposed to be in the first binomial and the 1 in the second. And when you do that, you get the right answer. So if I was factoring this and I realized it didn't work, I would just erase all of that, back up to here, and try it again a different way. Just remember that we've tried this way. So now we could change it to 3 times -1, and we also have -3 times 1. These are the 4 possibilities, because order matters when you have a 2x and an x. So it turns out that it does work when you do it this way, because that was our original problem. Let's try one now where we don't know how it started so that you can really see what I'm talking about. Now we have no idea what the original factors are, so we're really going to have to treat this like a little puzzle. It's a trinomial with no common factors, so we're going to jump into 2 binomials. All right, whenever it starts with x squared, you assume it's x times x. We're going to focus on this piece right here. because that's what we get when we multiply these two together. So negative 56 is a product of what two numbers? Okay, we've got, just looking at positive numbers, 1 times 56. I like to go in order when I build my list. Do you notice I have 1 and then 2? I'm going to continue doing that. Does 3 go into 56? No. Does 4? Yes. 4 times 14 is 56. Does 5 go into it? No. 6? No. 7? Yes. 7 times 8. When you get the next number that you would have picked, then your list is complete. So these are the only factor pairs that make 56. To get negative 56, one of them is going to have to be negative. Think about this. The sum of these two numbers we're going to choose is this, negative 1. The last example was tricky because of that 2x. If you don't have the 2x, then you're just looking for factors of 56 that add up to negative 1. So imagine that one of these numbers has to be negative. When you add a negative and a positive, it's really subtraction. So here's what I want you to look for. What two factors of 56 subtract to give you negative 1? Well, the only two factors that are 1 apart are 7 and 8. So I'm going to start with 7 and 8. But if I add 7 plus 8, obviously I get 15. So where does the negative go? With the 7 or the 8? Notice this is negative, so the bigger one has to be negative. And as soon as you find a factor pair that makes the negative 56 and adds up to the middle term, which is negative 1, you have found your answer. So let's put those over here. 7 is positive, so I'm going to put plus. 8 is negative, so I'm going to put minus. It wouldn't matter what order I put those in since the x's are identical in this case. Okay, if you want to check it, let's do the multiplication real quick. Remember, everything times everything. So x times the x gives me x squared. X times negative 8 is negative 8x. Then 7 times everything. So 7 times x is 7x, and 7 times negative 8 is negative 56. If you combine the like terms, you get negative x for the middle term. Is that the original problem? Yes, it is. So this is correct. That means that when I say factor this, the instructions will say factor. They won't say puzzle it apart. This is the official word we are looking for here. When I say factor this, this is what the answer looks like. It's two binomials multiplied together. Each of those is a factor. X plus 7 is a factor. X minus 8 is a factor. Here's another one. Now don't forget there was a first step that we're all supposed to check for, right? Is there a common factor in all of these? Yes, they're all even numbers, so 2 is a common factor. Divide them all by 2 and pull it out in front first. So that leaves x squared minus 2x minus 15. Now what you have is, it's kind of like if I had the number 8 and I broke it down into 2 times 4. Are those all the factors of 8? No, because 4 can be broken down further. Well, in this problem, x squared minus 2x minus 15 could possibly be broken down further. So we're going to try that. We keep the 2 out in front, but then write our potential two binomials here. This is like breaking it down into two factors. Since this is x squared, we put x times x. Now we're looking for a product of negative 15 and a sum of negative 2x. So first look at the factor pairs that make negative 15. 1 times 15, 3 times 5 are the only positive factors. One of those things has to be negative. And if only one of them is negative, then that means this is resulting from subtraction. Does this subtract to make 2? No. Does this subtract to make 2? Yes. So now we have to figure out which one to make negative. But one of them is a 3 and one of them is a 5. If we want them to add together to give us negative 2, then the bigger one must be negative. Because if the 3 was negative and the 5 was positive, that middle term would be positive 2x. And you can check it to see if it works. If you multiply this back together, we get x squared minus 5x plus 3x minus 15, and all of that is times 2. But first, let's combine like terms. So 2 times x squared minus 2x minus 15. I know that looks like a z, but that's how my 2's are. And then we multiply everything by 2. 2x squared minus 4x minus 30. Is that the original problem? Yes, it is. Therefore, the most factored form was right here. This is the answer with all the squiggle marks on it, preferably. Here's the last one we're going to try today. First, check for a greatest common factor. I don't see anything because x squared just is 1x squared and 48 doesn't have an x. So let's move on to breaking it into two binomials. X squared comes from x times x. That's the easy part, right? Now we need two factors of 48 that add up to negative 16. If 48 is a positive product, but 16 is a negative sum, how does that work? What factors are we looking for? You think about that while I jot down the factor pairs. So 1 times 48, 2 times 24, almost everything goes into 48, so this will take a little while. 3 times 16, 4 times 12. 5 does not go into it, 6 does, and 7 doesn't, and I'm back to 8 again, so I am done. Remember though that that's not the only way to get positive 48. You could also have negative 1 times negative 48, etc. So either both factors are positive or both factors are negative. Which way are they going to add up to negative 16? Obviously they have to be negative. So now we're truly looking at a sum of two negative numbers. This would be too big. This would be too big, right? 2 plus 24 is 26. That's just too big. 3 and 16 would be 19. That's too big. Getting closer though. Negative 4 plus negative 12 is negative 16 when you add them, right? So that's it. It looks like it's minus 4 and minus 12. Just check this. This times this is supposed to be 48, and when you do these middle ones and these outer ones, the negative 4x and the negative 12x, it's supposed to combine to make that middle term, which it does. So this is our solution right here. So it's kind of like a puzzle, and in this unit we're just getting started on factoring. It's going to be a main topic all the way through Algebra 1. No matter where you take Algebra 1, this is a big topic. So there's your introduction to factoring.